Today, I'll be presenting on wildlife responses to localized mitigation fencing and wildlife crossing structures. In Cameron County, Texas, 9 wildlife crossing structures were installed under Farm to Market Road 106 near the Laguna Atascosa National Wildlife Refuge. Their primary objective was to mitigate road mortality and habitat fragmentation for the endangered ocelot population, but the structures have been used by a wide variety of other species. Each structure is flanked by a segment of standard chain link fencing ranging from 50 to 550 meters in length. So rather than fencing off the entire corridor, this localized fencing is meant to funnel wildlife from the immediate surroundings towards a corresponding crossing structure. One of the clearest responses for wildlife that we were interested in documenting was fence end circumnavigations, where wildlife refused to use the underpass crossings and instead followed the fence segments to approach the surface of the roadway. We first wanted to establish, is this fencing influencing the presence and activity of wildlife near the roadway? Are wildlife circumnavigating the fencing as suspected? And if so, where, which species, and how often is this occurring? And finally, how do we go about documenting these circumnavigation events for comparison? So to begin to tackle these questions, we hypothesized first that fence end detections would show significantly different activity for all species when compared to crossing structures and unmitigated right-of-way sites. And next, that fence circumnavigations, while they may be occurring on occasion, will not make up more than 5% of site detections per species. We went on to collect over 6 months of data across 78 camera trap sites. This included cameras monitoring unmitigated right-of-way sites, which were located at unfenced sections of the roadway, as well as cameras located at the ends of each fence segment and at each crossing structure entrance. That looks something like this, replicated across the entire 15-kilometer study corridor. The results of our first analysis compared each of these types of camera sites and indicated that while wildlife crossings were distinct, fence end and right-of-way sites showed no significant differences in overall activity. This can be seen for some individual species as well, with several showing markedly higher or lower activity at crossings when compared to all other sites. So hypothesis 1 was partially supported, but the fact that fence ends and right-of-way sites did not differ significantly may indicate that fencing alone has little influence on the observed roadside community. To take a closer look at potential circumnavigation events, we documented interactions at crossing sites and fence ends individually, and then we compared the two, identifying any events where animals moved from the fence end to the crossing structure or vice versa. We then tallied the number of circumnavigation events that occurred at each transect of our sample site, identifying 6 species that exhibited this behavior. We then compared those tallies to the number of overall detections to test our second hypothesis, though the limited amount of data at this time prevents us from making definitive conclusions. However, for this particular site, bobcats, coyotes, and skunks were all seen circumnavigating fencing more often than the anticipated 5% of the time. And while these individual tallies may seem too low to be meaningful, repeated over time, they represent a potentially dangerous pattern of behavior for certain species or individuals, especially when managing for an endangered population, in this case, less than 20 ocelot individuals. Even a single road mortality incident may have an outsized impact in continuing conservation efforts. It is also worth noting that these numbers are likely an underestimation of circumnavigation behaviors, since cameras only monitor one possible route along each fence segment. Also, without definitive identification of individuals seen on camera, it is impossible to say whether this data represents a species-wide response or variation in individual behavior. Future studies should focus on identifying which fence transect characteristics, such as fence length or availability of canopy cover, might be associated with higher numbers of fence circumnavigations. And these results could then be incorporated into future designs or fencing modifications to prevent mortalities of target species in the future. Thank you for your time, and thank you for everyone who contributed to this project.